All right, thanks for joining us. We're solving equations in this lesson. I've got a few slides I'd like to work through with you that would help you to know how to solve equations. This is just the beginning of um, algebra, finding variables, using variables to replace something that we don't know. The last lesson was all about writing those equations, and now we're going to get into how you solve for those equations. So normally I would have a slide uh, shade or a screen shade here, but I think all these things are equally important and all work together. So I just had all three of them at the same time. Just get the variable all by itself. That's what you're trying to find out. You're solving for the thing that you don't know, and the variable is that thing that you don't know, so you're going to just get it by itself. And once you get it by itself, then you can perform the operations and find out what it is. As you do it, I'm just going to be going through just using these opposites. Adding is the opposite of subtracting, and multiplying is the opposite of dividing. And then I often do these curved arrows. If you're going this way and you're multiplying, then you should be able to start at the end and do the opposite and get back to where you started. So when you see those curved arrows, um, students in class would see me draw those arrows a lot. And that's what we're going to be doing here also. All right, so I'm just going to move to some equations and try and use some of these things we're talking about right now. All right, so here are many equations. An equation again has an equal sign in the middle. The left side is equal to the right side, and I'm just going to go ahead and solve some of these, or all of them. But you can see with this one we already have the variable all by itself. It's on one side all by itself. The numbers are on the opposite side, so we can just perform the operation. S is equal to 11. All right, this one you can see that n is not by itself. It's with minus 2 here. So we would like to get it all by itself. So I'm going to pull out these curved arrows I was talking about before. If I'm subtracting in this direction, then I should be able to start here at the end and work all the way back in this direction by doing the opposite. And the opposite of subtraction is addition. So 9 plus 2 is equal to 11. That means n, where we started, has to be 11. So working in this direction I subtracted, I have to do the opposite to get back to where I began. All right, with this one then, I've got f plus 8 is equal to 18. I'm actually going to rewrite it that way. I'm just going to take this side, 18, put it on this side, take f plus 8 and put it over here. So both sides, I haven't changed anything yet. Both sides are still, oh, there I did. So f plus 8 is equal to 18. Now again, if I'm working in this direction and I am adding, I should be able to start at the end here, and do the opposite, which would be subtracting. 18 minus 8 is equal to 10. And that means that f has to equal 10. 6 plus d is equal to 15. Now, we'll be talking about the properties real soon, but one of the properties is the commutative property or the commutative property. And when you're adding, you can take two things and switch them around and you'll get the same answer. So I would do that in this case. I would put d plus 6 equals 15. And again, now if I'm adding in this direction, I should be able to start at the end and come back and subtract. 15 minus 6 would be 9. That means that D would equal 9. All right. If we can go on to this next, I just had a whole bunch of multiplying and dividing problems here. Equations, I should say. So again, with this one, I've already got s on one side all by itself. So I'd have 2 times 6 equals 12. So s would equal 12. With this one, I don't have n by itself. I'm dividing in this direction. And so I should be able to take the end and do the opposite. Get back. 9 times 2 would be 18. So that means n would have to equal 18. 56 is equal to L times 8. So I can just put L times 8 on this side, 56 on this side. If I'm multiplying in this direction, I can start here and do the opposite, divide. So 56 divided by 8 is equal to 7. That means L has to equal 7. 64 divided by D is equal to 8. All right, it's a good time to talk about that commutative property we were talking about before. The commutative property or commutative property works well with adding and multiplying, but it does not work for dividing or subtracting. So I can't just take D and 64 and just switch those places because this is actually a division problem. And so since I've got two different, or this is a different problem than the way I've done the previous 7, this would be a good time to just talk about some other ways to solve some equations, so just different strategies. And one that could just be a simple mental math. And many of you were probably doing these earlier, saying, well, I can do these faster just doing mental math. And it's just saying in your head, 64 divided by what is going to give me 8? 64 divided by 4. Oops, that's 16. That's too small. I need to do something larger. So just simply saying, knowing your basic facts, D would be equal to 8. Okay. All right, so write an equation for the problem and then solve that equation. A cheetah runs 70 miles per hour. A lion runs 50 miles an hour. What is the difference in their speeds? So you have to set up an equation for that. 70 minus 50. See that word difference? That was one of our clue words we had talked about in the previous lesson. So that's a difference we're going to be subtracting. So the D is difference and it's all by itself right now. So we can just simply perform the operation. 70 minus 50 is 20. So D is equal to 20. Okay. Write an equation for the problem and then solve that equation. Ashley has 16 beads. She needs 24 beads to make a bracelet. How many more beads does she need? All right, so go ahead and pause the lesson right now and on this little sheet of paper that you have, go ahead and give this a shot. Ashley has 16 beads. She needs 24 beads to make a bracelet. How many more beads does she need? All right. Hopefully this went okay for you. 16 is what she has right now. She needs some more beads. And then she'll have 24, which is enough to make a bracelet. So this is the way it would have been written. Some of you may have seen more than, or how many more, and you might have done the subtraction problem. So maybe you would have written something like this. 24 is what she needs. She has 16. And this is how many beads she needs still. If you had something like that, that's totally correct. Many times in math, there's more than one way to solve a problem. In fact, let me show you how I did this. This is different than how I did the previous couple of slides. I'd like you to see, here's our original equation. And I said, well, B has this 16, plus 16 attached to it. So I'm going to try and unattach it or separate it from there. So in order to do that, I subtracted 16 from both sides. If both sides of an equation are equal, if I subtract 16 from one side over here, then I'll have to do that to the other side also so that those two equations, those two sides of the equation are still equal. And so when I did that, I had a 0 on this side, which is really nice because I wanted to have um, that letter B all by itself. So 16 minus 16 is 0. Now B is all by itself on this side, and 24 minus 16 is equal to 8. And B is equal to 8 then. Okay, so that's the beginning of how we solve equations. I gave you a few different strategies to choose from here. Um, so hopefully the beginning of solving equations and using the opposites of, adding and subtracting opposites and multiplying, dividing opposites will help you solve for those variables. All right, thanks.